All right, so we're going to be going over your homework. So your homework was just these two charts, and it was super straightforward, I think. I wouldn't necessarily say easy. You got all of the information from page 13. So we're just going back and forth from Celsius to Kelvin or Kelvin to Celsius and Fahrenheit, all of that. Now, I know in real life you would just use Google, and I know using Google is pretty easy. But this reference table isn't so bad. This one doesn't require a lot of thinking, maybe a little bit of counting, not sure. So you just have to find on page 13 the number they give you. So this is just a refresher. For example, they gave you 70 degrees Celsius. So all you have to do is find the number they give you. So they gave me 70 Celsius. And you could do this one of two ways. You could either, you're more than welcome to write on your reference tables. So you could take that 70 and draw a line over, or you could take like a piece of paper and just hold it up there. And you see that you're one line below the 160. Now these lines go up by what on the Fahrenheit side? 2's, which if you don't have that labeled, you might want to add that they went up by 2's on the Fahrenheit and 1 on the other side. So if I'm one line below 160 and they go up by 2's, what is 70 degrees Celsius? 158. Okay. Then we do the same thing over on the Kelvin side. So again, you can either take a straight edge, or if you wanted to go right ahead and write on there. Looks like I am 2 lines below that halfway mark is one way to do it, or I can just count up. So these lines are little. So there's 340, 341, 342, right on the 343 line. Any questions on how to read this one? All right, you can be off a little bit, but you got to be careful because if you said this was 359, I know that's only one number off, but that meant you didn't count right because remember they go by 2's. So this next one, I got 8 and -13. And then 104 and 313. And 15, 288, 62 and 16. Ooh, did anybody notice anything weird with this -40 Celsius? How weird is that, right? The way the math works out, that -40 Celsius is equal to -40 Fahrenheit. And you never know when that might come in handy. I actually won $100 on the trivia contest because I happen to know that off the top of my head. Fun fact. And then I got 233. It just said I won $100. Oh, I know you are listening to half my story. -27, -33, 23, 297, 122, and 323. Any questions on any of those? You got something drastically different? Something went wrong? No? Good. All right. Water boils was right on the reference table. It was 100 degrees Celsius. That was easy. And 212 Fahrenheit. And 373 Kelvin. Water freezes also. These are both labeled. Water boils, water freezes, room temperature. So freezes at 32 Fahrenheit, 0 Celsius, and 273 Kelvin. Now body temperature. Not listed on there anywhere. But come on, guys. How many times in the last year has your temperature been taken?
Oh, it's 97.
98.7-ish, yeah. So let's go with what did you say, 98? If you did that, I believe that's around 37 Celsius and 310. No, on the Regents, you will not be responsible for knowing body temperature. But come on, you're human beings. You should know what you're human beings during COVID. You should know what your temperature should be at this point in your lives. And then the last one, 68, 20, and 293. Any questions on any of them besides body temperature? How'd you do? Did you get them ish? Most of them? All right. All right, well then that's pretty much it for the temperature stuff. We do need to finish the notes down here. So we got to finish the notes at the bottom of the page. But there is nothing new I'm about to teach you here. So let's go through it. It says heating and cooling of air by expansion and compression. Heating of air. Picture heating up air in a hot air balloon. What does the hot air do? First of all, it rises. Now let's talk about the molecules. Why does the hot air rise? Let's think of individual molecules of air. When you heat them up, what do? They expand. And then remember, we talked about this in the beginning of the year. This is actually chapter 1 stuff. I talked about hot, sweaty humans. What do hot, sweaty humans do? They spread apart. No one wants to be near another hot, sweaty person. So hot, sweaty people spread out. So do hot, sweaty molecules. They spread out. They expand. When they expand, what happens to their density when they're spread out? They're more or less dense. If I took this class and I spread you apart, you're less dense, because remember, density means how tightly packed you are. So if you're spread out, you're less dense. So when air is heated, it expands. And when hot air rises, it rises because it expands and it's less dense. But now let's talk about the hot air that's up in the air, or the hot, sweaty humans. Once you're spread out, what starts happening to your temperature? You cool down. Now let's go the other way. If you're freezing cold and you have no other choice, what do? You get close to other humans. Again, I know most of us don't want to be near each other, but if you had no other choice and we were freezing cold, we would all huddle together. Molecules do the same thing. They huddle together, they become more dense. That's called compression. We're compressing them together and they huddle together. And when they huddle together, what's going to happen to those cold molecules when they're huddling together? They're going to warm up. You got this. So nothing you just said should have been new. And we're just going to put this refresher in our notes at the bottom of page, I know it's weird, but page 23. Again, page 23 is just the front cover. Lost it. Hang on. There it is. Okay, so these 4 bullets. When a gas expands, its temperature decreases. And this is because warm air rises, it expands, and its temperature decreases. So get those 4 bullets. I know 4 bullets is kind of a lot, but you can handle it. Oh, 8 years later.
Sorry, I forgot about it.
Thanks. So like I said, nothing there is new to you. We're just putting it all together with weather now. So warm air rises. Once it rises, it expands, or it's rising because it expands. And once it's expanded, just like you guys, once you're spread out, your temperature goes down. This all ties together with weather. This whole temperature change is the reason why we have a lot of different kinds of weather. And we're gonna actually flip to, if you're done writing that, you'll see up there that your homework's page 24. There's 7 regions questions. And then we're gonna go to page 25 and start talking about air pressure. What's pressure, guys? If I said to put pressure on a wound, what do? You push down on it. So what do you think air pressure is? Air pushing on something, yes, 100%. Is everybody good if I slide this forward? So air pressure is the weight of the air pushing down, or the weight of the atmosphere. And how much air pushes changes depending on temperature. This is the first bullet, is that page 25 we're on now? Page 25, the first bullet on page 25. So if I say put a lot of pressure on a wound, you're pushing really hard on it. If you don't need to put as much, they have lower pressure on it, you're not pushing as hard. Air pressure is the same thing. Sometimes air pushes really hard down on us, and sometimes it doesn't push as much. You've actually probably even noticed this sometimes if there's different times where pressure changes, but recently the temperature changes will actually affect how much pressure is on your sinuses. Some people may have noticed this past few days, your sinuses are all weird. You're either feeling like there's a lot of pressure pushing down on your face, and giving you like a sinus headache, or even the other way, once that pressure releases, sometimes people get headaches too. So let's talk about this. Cold air does what? Actually, we're not there yet. Let me keep going. So air pressure. It is measured with, does anybody have any idea what instrument we use to measure pressure? Some people might know, most people don't. I don't think so. It's called a barometer. So the instrument is a barometer. You will need to know that off the top of your head. So just as fast as you know thermometers for temperature, you need to remember a barometer is for pressure. And also, this one you don't need to know off the top of your head because it is listed right there. There are 2 different units we use, and they are called inches of mercury or millibars. So a barometer, depending on which set of units, will either measure in inches of mercury or millibars. And on a weather map, does anybody remember how we show pressure on a map? We did it in chapter 2 back in October. Connect the dots for slightly older kids. Isotherms are for temperature. Anybody remember? No. Isobars. So that's the next one. Shown on a weather map with isobars, lines that connect places of equal barometric pressure. If you see barometric pressure, it just means air pressure. But you can see where they got the bars from. That's from barometric pressure. And the last bit of notes, we're gonna do some more practice, but the last notes is the next section and it will take up a little bit of writing. We're gonna talk about how a barometer works. So again, I mentioned, okay, I'll just put this picture up here and then I'll talk a little bit. So I mentioned that your sinuses may have been messed up these past few days. Let's talk about why. So what does cold air do, guys? Cold air, where does it go? Okay, let's do it the easy way. Where does warm air go? Okay, wait. Warm air
Right.
rises, so cold air goes out, sinks. Good. Do you mind if I push on your shoulders for a second? Thanks, Connor, you're the best. So cold air is sinking. So if my hands are cold air, I'm pushing down on Connor's shoulder. He's so much pressure, he practically fell out of his chair. Same thing's happening to your sinuses. When the cool air is sinking and pushing on your face like this, and it's messing up your sinuses. That's why you might feel that pressure in your head. Same thing happens with their ears, but we're not going to go into that because that's temperature or that's difference in pressure, not because of temperature. I want to talk about temperature. So that cold air sinks and pushes on your shoulder or pushes on your face and you feel the high pressure. Now warm air, where's warm air go? Rises. So so it's pushing down when it's cold, but then when it warms up, notice how his shoulders lifted right back up. You are perfect at that demonstration. Okay, cold air sinks and pushes down on you. Warm air lifts up and you feel less pressure on your shoulders or your sinuses. That's how this works. So instead of Connor's shoulders, we have a dish of mercury. Now these are the old-fashioned ones. They don't use mercury anymore. We have a dish of mercury and basically a test tube that has little marks on it that are marked up in inches. So hence the inches of mercury. Well, when that cold air pushes down, just like I pushed down on Connor's shoulders, where's the mercury go? If I'm pushing down, it's going to go down in the cup, but it's going to go up this tube. So if I push down on this open bowl that's got this tube in it, it'll push down, and where's that mercury going to go? It's got to go up the tube. It has nowhere else to go. So when you push down, the pressure goes up. And then when there's less pressure, just like Connor's shoulders adjusted, instead of it being pushed down, it goes up, which will drop the mercury in the bowl. 3 bullets that explains all of that in words. When you're done writing this, there's no more words to write. We're just going to do some practice with pressure. This will take you a minute. I'll let you copy it down. When you're done writing, grab your reference table if you don't already have it out. We're going back to page 13, so the same place we were in a few minutes ago. So it says using pressure conversion chart on ESRT, page 13, complete the tables below. So just like converting temperature back and forth between Celsius and Fahrenheit and Kelvin, we are going to be converting using, so it's the same reference table page. There's a pressure chart off to the right-hand side. So it works the same exact way. I have millibars on one side, inches of mercury on the other. Now, I think the inches, or I'm sorry, the millibar side's the easy side. So let's take a look at the millibar side. We'll start at the bottom. Goes from 968 is the first labeled one to 972. What are the lines that aren't labeled counting by? Go ahead and give it a whirl. Look at them. See if they're going up by ones, twos, tens, 15s. They are going up by one. So 968, 969, 970, 971, 972 is labeled. So this one, I'd like you to add a label up there. It goes up by one. So that's a +1 if you can't see what I wrote there. +1 on the millibar side. Meaning and maybe add goes by +1. Maybe that helps you remember why you're writing that. So what I'm saying is those little lines go up by 1. Now let's look at the inches of mercury side. This one's a little weird. The first one they have labeled is 28.5 and then 28.6. So what are those little lines going up by? Point what? 0.01. And I actually just want to talk about this real quick, where this comes from. Again, it's in inches of mercury. Actually, this doesn't do a good job of showing it. So those are inches of mercury. So if this is 28.5 inches, that's 28.6 inches. These little lines are going up by 0.01. And I want to show you what that means. There, I labeled 0.01 if you don't know. Here's what I would like you to do. I want to expand this area. So that first line is 0.5, 20. Here, I'm gonna have to do it up here so that I can blow it up. What I'm trying to demonstrate, which is not going well for me, is that this line, I'm gonna give Brandon one up. This is like my first day. So we've got this 28.5 here. What is that next line that's right above it? 28.51. Then what's the next line that's right above that? Guys, everybody got this or just Victoria? And then what's the next line up? Not 28. So 28.52 is the last one. What's the next one? 5.3 and keep going. 28.54, 28.55, 28.56, 57, 28.58. Oh my gosh, we're running out of space. 28.59. What's the next number? 28.6. So that is what it looks like in that little section. People have been struggling with that all day. I recommend maybe putting that in your actual reference table to help you out. Just that one set if you can't just glance at that and see it. So all I did was expand one set there, so you know what they're going up by. Yeah. So then we're gonna need to go back and forth for in our notes. So, or not in our notes, our reference. Oh my gosh. This chart is asking you to convert inches of mercury into millibars. So we're going to take that. The first one is 29.06. Everybody on your reference table find 29.06. 29.06. We're going to come around. It's on your reference table. So on your chart here, find 29.06. The point to 29.06. Got it? Here's 29.06. Everybody find 29.06. So here's 29.0. I'll do it here so it's recording. Here's 29.0. Here's 29.1. No, it's not 29.01, 0.02, 0.03, 0.04, 0.05, 0.06. Right there. How many millibars is that then? It's not 985 because that would be the next full line up. But you're right, it's not on the 84 either. Point something, what's right after 0.0 then? 0.1, I agree with you. That is 984.1. So again, where did that come from? It wasn't right on the 984, but it wasn't all the way up to the 985 either. It was just a smidgen above 984 to 984.1. Let's go on the other side. They're going to ask you to go the other way. They're going to give you millibars and you have to change it into inches. So the millibars is 1,011. There is no 1,011 labeled on here. Where is 1,011? How would you describe 1,011 on this chart? You got it. The line under 1,012. Where'd my pencil go? I lose more writing utensils up here than you would imagine. All right, well, I guess I'm using a pen this time. Wow, oh, there it is. So here's 1,012. So here's 1,011. Is that lining up exactly? That's pretty darn close. What line is that? 29.85. So there's 29.8, 29.81, 82, 83, 84, 85. Can you guess what I'm going to ask you to do right now? Finish. There's three. Oops, 5. There are 3 more on each side, so 6 total. Give this a whirl in the next couple of minutes. This isn't homework. This is do right now work. All right, let's go over some of these. We are almost done. So if you haven't already written it down, or if you didn't notice, your homework is page 24. There are 7 questions there. Let's make sure you got these pretty closely. What'd you get for 29.94? I agree, 1,014. How about 30.5? 1,033. And 29.44? What? 997, I agree. We already did the first one over there. How about 1,021? 30.15. 1,035? 30.56. And 991. 29.26. Good. All right. So like I said yesterday, or no, yesterday, oh my gosh. Like I said 5 seconds ago, your homework is page 24. Make sure you get that done. Also, if you are not happy with your test grade, remember test corrections are due by Monday. And just an FYI, the 5 weeks is over on Friday.